So for these problems, we're going to identify which type of reaction is taking place. Our three choices are acid-base, precipitation, or redox. And then we have to be able to explain how we know that. So usually it's easiest to first eliminate our precipitation reactions. So for it to be a precipitation reaction, we have to have two aqueous solutions going together to make a solid. Here we do not have two aqueous solutions, nor do we have a solid as a product, so we know that this cannot be precipitation. Next, I would eliminate acid-base. Acid-base is defined as a transfer of a proton. So here we have a hydrogen ion, also referred to as a proton, and that's going to transfer a hydrogen to the hydroxide. And that's how we get H2O over here. So this must be acid-base. And when it says explain, be specific. So HClO4 transfers a proton to copper 2 hydroxide. The acid always transfers a proton to the base. So that top example, again, we don't have two aqueous, so it's not precipitation. It's not acid-base, so we do have a hydrogen, but that hydrogen isn't combining with manganese. Manganese is combining with bromine, so it can't be acid-base. So this must mean that it must be redox. If it's redox, we need to go through and assign oxidation numbers. If you need help on that or remembering, then go back to the redox video. So Mn is by itself, so that should be a 0. Hydrogen is diatomic, so that should be a 0. Hydrogen is a +1, so that means bromine's -1. Bromine and manganese, we don't have a rule for either, so we're going to revert back to what we know, that bromine is a -1. We have two bromines, so manganese must be a +2. So this is a redox reaction. Manganese's oxidation number, again, oxidation number, not charge, so it went from a 0 to a +2. So manganese was oxidized, meaning it lost electrons. While hydrogen's oxidation number went from a +1 to a 0, so it was reduced. So if it's an oxidation reduction reaction or a redox, make sure you're being specific on the oxidation numbers. Don't just say manganese and hydrogen's oxidation numbers changed or electrons were transferred. Be specific on who's oxidized and reduced and how we know that. All right, go ahead and pause the video and try this next one on your own. Restart when you're done. So you should have said redox. Mercury's oxidation number went from a +2 to a 0, so it was reduced, while oxygen's oxidation number went from a -2 to a 0, making it oxidized. Go ahead and pause the video and do these next two on your own. Restart when you're done. So that first one should have been precipitation. We had two aqueous reactants producing a solid precipitate. Make sure you know that that solid precipitate was barium sulfate. So this one was redox. Oxygen went from a 0 to a -2, and then carbon was a little tricky. We have hydrogen is a +1, and we have 10 of them, so that's +10. So carbon is 10 divided by 4, or a -2.5. So you can't have a negative or a decimal oxidation number, and that's what happens here in 2.5. butane. So your full answer should have been redox. Oxygen's oxidation number went from a 0 to a -2, meaning it was reduced, while carbon was oxidized, -2.5 to a +4. I'm going to try this last one and restart when you have your answer. So if you said acid base, you're correct. And then you should have said that a proton was transferred from acetic acid to sodium hydroxide. So that hydrogen combined over here with that hydroxide, making water.